When we talk about continuity, what we're really saying is, fluid is flowing along and it's not disappearing anywhere. It, what goes in on one end of a pipe comes out the other end. If you're talking about air flowing along, none of it disappears. It's still all there. And so that's really what continuity means, that it's not just magically going away in some way. It still exists and it's still moving. And flow rate is really just if you look at a volume here, and there are all kinds of flow rates. We could talk about flow rates in terms of what was the flow rate of supplies to Berlin during the embargo from the Russians. Um, so here we go. The flow rate is really just if you look at a piece of fluid which has some volume. It's got an area and it's got a length. This area is a cross-sectional area, so that the volume is just A times D, area of a cylinder. It's moving along at some velocity. So if you could just kind of keep your eye on this chunk of fluid, you could watch it move. Well, the flow rate or the flux um, is just the flow rate is just the volume per unit time that's flowing along. Um, and so you know, Um, that's really all it is. And the flow rate is cubic meters per second because cubic meters is volume. And if we look at this and we look at the fluid velocity in terms of all of this, well, it pops out to be the fluid velocity times this cross-sectional area is the flow rate. So fluid velocity, however fast this fluid is moving, times the cross-sectional area is the flow rate. And that's all pretty straightforward and simple. Um, if we look at what happens when the cross-sectional area changes, because what comes in has to go out and it can't disappear, right? Because of that, and if we look at the flow rate here and the flow rate here, they have to be the same. And so if we look at Q is A1 times V1, and over here Q is A2 times V2, what we get is V2 is A1 divided by A2. All right. Nope, that's supposed to be V1. Pardon me. Q is A1 over A2 times V1. So what are we doing here? Well, this is exactly what you do when you use a water hose and you need to spray it farther. You put your thumb over the end of the hose. You make the area that it has to come out of smaller, and that increases the velocity of the water coming out of the hose from what it's doing back further in the hose, because you've created a constriction to increase that velocity. And that's what we really mean by flow rate and and how this all works together. And you've got this flow rate Q, right? A1 V1 equals A2 V2. That's all part of continuity. And back to more fundamentally, Q is volume per unit time that's moving along. All right, that's it for this part.